How many are you here for story time? Sweet. Is that loud enough? Yeah. All right. Well, so I'm going to introduce myself. I am Troy Jessup, also known as Jupiter. You probably know that already. You've seen me around maybe a little bit. One of the things that I do for my day job is I run cybersecurity and network operations for the Utah Education and Telehealth Network, UETN, or now we're kind of simplifying it back to UEN. Long story, just know that it's the same organization. I'm here to kind of talk about an incident of sorts that we were part of or saw that I think has some important lessons that need to be learned for our cybersecurity community. The reason why I want to bring this up is we're going to talk about some deeply technical IP routing things. How many of you guys have heard of BGP protocol before? Okay, that's awesome. Does anybody know how it works?
Nobody does.
The one guy, there's a couple of ins out here, okay? We are going to talk a little bit technical about those things, or by we, I need to introduce, you can just wave over here for a minute. This is Steve Wallace, flew all the way from Indiana to come and give this talk, and then he's doing a turn and burn right back out. So give him a round of applause at the end, or now. We appreciate him being here. The reason why I reached out to Steve is because he is the industry expert in route security for these types of things in the country, maybe the world or beyond or whatever. He's going to be very humble and say maybe for Indiana or something, but he works for Internet 2, and I'll leave all of the rest of the details about himself if he wants to share when he comes up here. But we experienced, and it's going to take a second. Okay, yeah, once upon a time. This is the slide I was going to start on. So once upon a time, back in a month, sometime in the summer of 2024. Oh, sorry, actually, we're going to go further back in time. I forget that I was a little tired when I built these slides. In the October of the year 1998, an IP address block of 222.33.0.0/16 was advertised via BGP for the first time, okay? The IP address block up here is hypothetical. It's, whatever. But let's just think about that for a minute. Everybody knows how a BGP or a route announcement works on the internet. You have a BGP peer, you announce an IP address block. We advertised this block for the first time via BGP back in 1998. And it worked. Hey, great. We can route things to it. In October of the year 2003, this IP address block was allocated on our network to critical services. Let's just say things like PII, PHI kinds of web application services that might be commonly used, okay? Again, I'm speaking hypothetically, but this is a real scenario that's happened. And I'm doing that just to not out a specific organization or group. But part of this address block, you notice this is a /24, not the /16, was allocated to critical services made available online, okay? Yay, it worked back in 2003 when this was turned up and things. Many years later, with little or no changes to how it was being announced or routed, something interesting happened, okay? And let me see what my next slide is. Yeah. Hold on. So something interesting, I'm gonna explain the interesting thing. All of a sudden, the services for that network became unavailable. And we went, we checked all of the services, and the servers are up, everything's working, the DNS servers are up, connectivity is good, you can route and ping all of the different systems and services and everything else, but nobody from anywhere on the internet can get to these critical services. The heck's going on? What's the first thing that you might troubleshoot?
The other one of the cross website the code got the routing file.
Okay, you could call somebody up, but would that be the first thing that we would jump to? No, it wouldn't be, right? Like, we would, is it up? Have you tried turning it off and back on again? Right? Can you ping it? All of those things work, but somehow it's broken. You can get to it just fine inside the office. It's working great. What's wrong? Okay. Well, what interesting thing happened was that somebody somewhere else on the planet, and again, a hypothetical ASN, I'm blaming it on Clippy since he's kind of the bad guy this year. But Clippy announced a more specific route of this IP address block, the same one that we were talking about before, somewhere else in the world. What happens when a more specific address block gets advertised? It's the priority route for that traffic, okay? And so if somebody can make a more specific announcement, and a /24 is the smallest block of address block or space that can be announced on the internet and actually work. And so they announced this small block, which is still a lot of addresses. All of that traffic goes somewhere else. This is what happened, okay? All of a sudden, all of the critical, or all of the services that somebody's trying to log into or to access, the traffic for this is being routed to the other side of the world, and we have no idea what's on the other side. Scary? What if somebody has turned up a malicious server to listen or to try and grab credentials? Okay, so this is one of those interesting vulnerabilities that you might not even be aware that's out there. Okay, and so part of the reason why I want to bring up this part of the story, and before Steve takes the stage and tells us all of the cool solutions and how we can address this, what I want you to leave this presentation with is you as the security and IT professionals, as part of larger organizations, need to start asking your router geeks that sit in the basement that have the tinfoil cubicles and all, that all they do is the green lines going up their screen kind of stereotype, which we're part of. I mean, we'll admit it, right? But those people that are in charge of IP routing for your organizations, have they done something to prevent somebody from stealing your IP address block? What happened as a result of this, and Steve's going to take you through and show you some of the complications and other things, but what happened as a result is for a period of time, critical services were unavailable, and we have no specific, I mean, we do now, but in this case, but it could have been routed to anywhere. And we might not know what happens to it. So it caught us. Those of you that have organizations that do your own IP routing on the internet need to know about this. And so without further ado, I'm going to invite Steve on up here to the stage because we talked about, was it a mistake? Because sometimes when this happens, this kind of thing is because somebody fat-fingered a route filter on an ISP on the other side of the world or whatever, but it can be pretty devastating. So is that a good enough intro to the story? And then you can finish the rest. Ladies and gentlemen, Steve Wallace.
But so there's no solution. What?
Unmuted now. Okay. Can you turn it down just a little bit? First of all, this is a fantastic conference. Troy took me around on a tour, and it's just unbelievable. So I'm happy to be here. Really happy to see what you guys are doing. So I'm going to give you an introduction to something I call the Routing Security Easy Button. We're going to repeat a little bit of the story Troy told you, still with no specifics, although there is one specific we'll share. The Easy Button is just one of a set of actions you can take to improve the routing security of your network. Routing security is essentially ensuring that the packets are going where they're supposed to go, that they're not taking a detour, and that they're actually getting through. And so those things you can do to make sure the network is running. Sometimes that's a bad thing, right? Because, all kinds of cyber attacks require that the network be working. And this particular kind of security is to make sure the network is working. So how many of you work for organizations that have their own IP addresses? Okay, this message is directly for you. This QR code is a link to the slides, and I assume they'll pass the slides around because there are links in the slides that may be useful. So early in July, I was on vacation at a ranch in Colorado, And the day after I arrived, I checked my email. They had a satellite-based email system there, not Starlink. I checked my email, and I got this email from somebody in Utah. It says, "Hi, Steve. Here's a fun one I'm hoping you can shine a light on for us. We own this network address, and we announce it to the internet as a /16, but we, as Troy mentioned, we allocate it to different customers, and there's this 24 that's being used for critical infrastructure that's now being announced by a network in the Philippines." Now, the AS number I give here is not the real AS number, nor are the IP addresses. Is there something we can do to mitigate this on our end? And I'm like, oh yeah, there's exactly something you can do, and it's the thing I call the easy button. So, giving a little more explanation. So this network in Utah announces their network is a /16 to the internet. And so the BGP protocol is telling the internet, hey, this network in Utah, AS12345, is the route to those sets of IP addresses. And normally that's just fine. It's working all the time, right? Apparently it's been working since 1998. Well then, in July, a network in the Philippines starts telling the internet via BGP, hey, there's a subnet that we're the way to get to that subnet. So send traffic to us. And Troy talked about the longest prefix match. It's not the highest priority route, it's the only valid route. So when you have a set of routes, the only valid route is the longest route that matches the address of the packet. So a longer route is not just a higher priority route, it's the only valid route. So all of a sudden, the entire internet is going, oh, to get to that subnet, I've got to send traffic to this network in the Philippines. So here's the easy button. Here's the mighty message. It should be on everybody's checklist. You can create a record within Aaron. We'll talk about what Aaron is in a minute. Aaron has a service that they don't charge extra for, where you create a record, and there's only 3 fields you fill out in this record. You tell it what network is allowed to announce these IP addresses. And this is called RPKI ROA, Route Origin Validation, or Authorization, sorry. So RPKI is a resource public key infrastructure that Aaron operates so that you can create assertions about internet numbers, so IP numbers and ASs. And so you fill out this form, you literally just log into your account and you fill out this form, and it creates a record that many networks in the internet pull in periodically. And when they receive a route that's in violation of this record, they don't accept it. So the problem is this is not really well adopted. And there really aren't, if it's done correctly, there aren't any downsides if it's done correctly. So it's an easy form to fill out, but you have to fill it out perfectly. Because if you fill it out incorrectly, as soon as you fill it out, you could take your network down. So it's not something you do without planning, even though it's a simple form. And creating these should be a checklist item for CISOs or other security professionals at organizations that have their own IP addresses. In fact, only the holder, you would call it the owner of the IP addresses, can create these records. So your ISP can't create records for your IP addresses if they're yours. You know, if they're the ISPs, they can create them. So only you can do it. Now there are ways to delegate some of that capability to others, but basically it's on the holder of the IP addresses to create these records. This is literally the form you fill out. There's no other form. And as soon as you do it, you receive protections against somebody borrowing your IP addresses. And as Troy said, you know, this happens accidentally in the internet. It could happen on purpose. It could happen in ways that you don't notice. So for example, a network might borrow a subnet on your out of your larger network. They might borrow it for an hour and do a phishing campaign using it. And you might not know. Or they might divert your traffic, still return it so the service doesn't go down, and watch or intercept, be a man in the middle for your internet traffic. And while this form, filling it out, doesn't protect from all sorts of cases like this, it does protect you from many of the cases. So
That's me. I was going to chime in. Go ahead, I'll get him.
Test.
Go ahead.
1, 2, 3. What? Man, I'm hot. It's a hot mic. So,
Guy.
so one of the things that I wanted to interject here into the story is Steve is mentioning also that that not everybody supports the receipt of these ROA records or enforces them. And there are some major ISPs out there that don't. Are you going to cover that part and stuff? Okay, I'm not going to steal his thunder, but we ran into some of those issues and things. Go ahead real quick.
Very hour, what you said, this is hours. Think about why they have to.
So I have a slide for that. But the short answer is all of the regional internet registries, and there are 5 of them, allow you to do the same thing, and their form looks similar, but they don't look the same, and that's a problem, and people are working on that. But they...
Back. Were you in a where I can... No. If we own the IP address space, it's already taken care of. If you own the IP address space, you need to hear this stuff.
So when you create this record, most major ISPs pull these records in periodically, and they check the routes. And if there's a route in violation with this record, they just throw it out. And I have a link coming up that'll show you how to test whether your ISP does it or not. Now, one of the things that happened in this particular incident that we're being somewhat obscure about is that, of all places, Google's backbone doesn't do this. And so I wish I could have said they filled this form out and everything was better. They filled this form out and almost everything was better, except those web pages had embedded in them links to Google. And because Google was still accepting this 24, Google itself was routing things to the wrong place. This is a problem Google has. They're not doing something called route origin validation. Now, most of the major ISPs are. Internet 2 is. Most of the traffic on the internet traverses, almost all of it, traverses networks that do route origin validation. I speculate, it's only speculation, Google builds their own routing infrastructure, and this may be a feature that they have not implemented and deployed yet, but I expect they will. Everyone else is doing it.
What I want to chime in on, I am here. Stand up here loud.
One of that.
So, and I hope you're okay with me just jumping in on your presentation.
No, it's fine.
So one of the things that I wanted to mention here about that Google scenario is that this service, this critical service that we're talking about, did have the need to have embedded services from Google, things like CAPTCHA. How many of you guys use CAPTCHA in some of your web apps and things, okay? These are the types of things that got routed because Google doesn't participate in ROAs or ROVs.
Route origin validation.
Yeah. That traffic was still set out, so that there was still downtime and still impact because of this type of thing. And there were but what I do want to say is once we put this in for this particular subnet, it did make things a lot better. Meaning there's enough of the bottom, or what do we call it, tier provider or tier 1 providers that are doing this, that it significantly improved the experience. And there were a few pockets out there that were impacted still.
So this slide is just depicting the fact that once you create this record, most of the internet will look at those records and be able to distinguish between invalid routes and valid routes. So I talked about Aaron. Aaron, for most people in the room, if you have your own IP addresses, they're registered with ARIN. So ARIN is the regional internet registry for Canada, the US, and part of the Caribbean. There are a total of 5 internet registries. I have them listed here. And if you have IP addresses and they're registered with ARIN, you probably have someone who has a login to ARIN. And they can go into the routing security section in ARIN. And I have links to show you exactly how you do this and create those records to prevent this kind of hijack. So I think this is going to become a standard of care issue. And one of the reasons is that it's gotten a lot of federal attention this year. So the FCC came out with a notice for proposed rulemaking, I think that's what it's called, essentially saying that they intend to require ISPs, tier 1 ISPs, to create and maintain ROAs for at least 90% of their IP addresses. And they also want those tier 1 ISPs to help the smaller ISPs do the same. But the problem is nobody's helping the enterprises. And in fact, when you look at the statistics of which networks create these things, the large cloud providers, the large ISPs, they're doing it. What's missing is the enterprises. And in fact, there's a correlation between the size of the enterprise in terms of how many IP addresses it has or how many ASs it has and whether it's created these records. And so that's a real big problem. My job within the research and education community is to try and work on that problem, but I don't see anybody in other sectors doing this. So the ISACs don't have, as far as I'm aware, projects to communicate this, help people with this. So I think that many of the enterprises are losing out on this fairly easy fundamental protection. The Office of the President, Office of the National Cyber Director came out in September with a pretty detailed roadmap where they basically say government needs to do this for all their IP addresses and everybody else, every network needs to do this. It's actually a pretty good roadmap. It covers the topic well. Link in here to that. So there's a corner case. Maybe you don't hold your IP addresses, but you get IP addresses from your ISP. Well, you might want to check to see if your ISP is doing this because it's important to protect your infrastructure. And there's a link, is bgpsafeyet.com. This is a service that's operated by Cloudflare. And it will tell you a couple of things. First of all, it will tell you if the IP address you're surfing from is protected. It'll also show you a list of the major ISPs and which ones are doing this and which ones aren't. Now, it's a particular problem, as I said, in the ARIN region. So this is a chart of the adoption in the last 5 years, and you can see that in the RIPE region, which somebody over here mentioned a second ago, so this would be essentially Europe, it's close to 80% of adoption. In other words, 80% of IP addresses have this protection in that region. But if you look at ARIN, we're down in the lower 3, and we're at less than 40%. And the higher education community in the U.S. is around 20%. And again, that kind of aligns with the size of the organizations, that the word isn't getting out. So in Amazon, knows they need to do this to protect their resources, and they have automation so they can take this task on and automate it and all those things. But when you're talking to a school system or a regional network or a Fortune 500 company that maybe has a handful of allocations from ARIN for a few locations around the country, this is something that they're probably not aware of. And they're not taking advantage of. And it's easy to take advantage of. Okay, so again, it's easy to fill the form out. It has to be filled out perfectly. The staff that have the knowledge that can fill it out perfectly are the same staff that are your BGP savvy network engineers. So a CISO or other security professional might put this on the list. We've got to do this, but the right people to do this are probably the folks that are most familiar with BGP. I have some links in here, a video that Aaron produces on how to create a ROA. The challenge with Aaron's video and most tutorials on how to create ROAs is they just cover the simple case. And so, for example, this incident we talked about when I showed you the form, except for the numbers being different, this is the form that was used, and this was all they had to do. And this was a particularly simple case. So if your organization has a /24 or /16 or whatever from Aaron, and you only announce that as a /16 or whatever, and you don't have a DDoS scrubbing service provider, and you don't have this broken up in different locations, then it can be really easy. There might be just one form. But I'm going to show you some examples of where it's a little more complicated and it takes some planning. And the examples I'm going to show you are not exhaustive. So, you know, a BGP savvy person can probably figure out which camp you're in. Ours is simple. We feel comfortable doing it. Ours is a little more complicated. We need to do some planning to do it. The other thing I'll tell you, and this is, I think, an underused resource at Aaron. If you log into Aaron, there's another website you can log into with the same credentials. It's called OTE, Oscar Tango Echo.aaron.net. And that is a test environment at Aaron. And it looks like your account at Aaron, except the things you do in there don't show up in real life. So for example, you can go in there and create these, you can fill these forms out and then go look at what they look like in that account and get comfortable with the user interface and how you do it without actually doing it. And I think it's either every 10 days or every 30 days, they make a new copy from the production environment. And so you could create a row in the test environment and it will disappear maybe at the end of the month or something. But at least you can get practice with an interface you may not have used before. I believe it's the case that if you automate your interactions with Aaron, because they have APIs for this, that you can use the APIs against the OTE environment as well. Okay. So we have a link to how to create a ROA, simple case. I have a link to how to plan a ROA, which is the thing missing in most of these, how to do this thing. And there's a link to the video in here, and I'm going to go over some of that in a few slides. Some of the barriers to doing this, at least the barriers that I see. Some people have IP addresses that were allocated before Aaron existed. These are called legacy IP addresses. Now, in the community I come from, many institutions, in fact, 2 years ago, about 50% of the institutions, the main institutions in the higher ed space in the US, had legacy IP addresses. Aaron provides services, like who-is services for those IP addresses, but those legacy holders don't have an agreement with Aaron. And you have to have an agreement with Aaron to use the routing security services. So one barrier, at least in the higher ed community, is maybe I never signed an agreement with Aaron, so I've got to sort that out. You know, it's new and different. So this, you know, the user interface is not the user interface people have used before. The concept's new and different. And, you know, there's a little anxiety there because you have to do it perfectly or you could create an outage. That doesn't happen very often, but I know at least one case in our community where that did happen. Another common one is, yeah, we have addresses registered with Aaron, but that person no longer works here, or we don't know what credentials are used with Aaron. And in the term that's good to know is Aaron describes fixing that problem as recovering the organization. So you can open a ticket with Aaron and say, I need to recover this organization that holds these IP addresses, and they will have you go through a process to gain access to that organization. As I mentioned before, if you have a DDoS scrubbing provider, depending on how they operate, you may need to have these rows that you create, this form you fill out. You may have to fill it out more than once or fill it out slightly differently to ensure those services continue to work as you expect. But the biggest problem, it's not on anybody's list. So I think this should be standard of care, that it should be on a list of things you actually need to do. And this is the first time I've got to talk to mostly security professionals rather than the networking professionals. And, it would be my hope, and I think Troy expressed the same wish, that you might take this back to your organizations and say, this is something we should do. It doesn't cost anything. For many of us, it'll be real simple. If it's not real simple, it's not too complicated. We just have to put a little energy and make sure we get it right. And maybe that means someday you won't wake up in the middle of the night with your organization saying, hey, there's critical services people can't get to. Because for this particular kind of problem, there's no other solution. It's not like you can call the network in the Philippines and say, stop doing it.
You could try, but it doesn't work.
Yeah, it doesn't work. You guys know it doesn't work.
Yeah.
No, thank you. Let me add my voice to this point as well and just say it's not on the CISO's list. How many of you guys knew about this problem before we had this talk today? Okay, a few. That's great that there's some of you doing that. Part of the reason why I wanted to invite Steve out here to talk about this in a forum, in a cybersecurity conference, because normally, if you might be familiar with NANOG or some of these other network operation group conferences where you get the guys who are typing in the BGP filters and doing all of that stuff, those people attend those conferences and they hear about this. I can guarantee that if you go into the person that's managing your internet routes and you say, hey, what's our RPKI ROA status? They're going to be like, how did you know those words? Right? They're going to have heard about it, but because of any of these barriers, or maybe others that are political or organizational, they're not making some of this progress. And we're hoping, and the reason, again, why I'm bringing this to this conference is we want the security professionals in these organizations to go ask the question, do you have an RPKI ROA set up for our IP address blocks? And if we don't, what's it going to take to make that happen to reduce our risk of somebody in the Philippines announcing our IP address space and taking us offline without our consent or any remediation capability? So that's why he's here. And I just wanted to make sure that you heard that from me right here on that slide. Thanks.
So RPKI rows, RPKI rows are what I call a routing security easy button. No configuration on your gear at all. You don't have to change anything in your network. You don't touch a single thing in your network to take advantage of this. But there are some other things that are part of routing security. And Internet 2 publishes a self-assessment. It's basically a control matrix for routing security controls. There's a link in the slide to get it. It's just a Google sheet that you can do a self-assessment, and it covers the kinds of things that are in something called mutually agreed norms for routing security, or manners. These are a set of practices that the industry, when I say industry, the network operators, the large network operators have come together and said, these are things we need to do to ensure the stability of the network. But those same things apply to smaller networks. We think IPv6 deployment is actually very critical, including having Quad A records, meaning that your devices that are your important devices that are facing users have DNS records that result of V6 addresses, so you're actually taking advantage of V6. Multi-factor authentication requirements for network node authentication. It's amazing how many organizations haven't done this. They may have MFA for their critical servers, and their users are using MFA now, but the network engineers are not using MFA to configure and operate the core networking equipment. That's very common. You should have some form of distributed DDoS service mitigation, or at least have something in the wings that you can engage quickly if you don't want to pay for it yet, but at least have researched it so that when that happens to you, you'll be able to recover. Doing monitoring of BGP routing is a good thing. So, we talked about creating a ROA prevents hijack. There are some kinds of sophisticated hijacks that the ROA won't fix. There are things coming down the pike that will fix them, but a ROA won't fix it. So it's important for some organizations to monitor the internet to notice if somebody's trying to announce their IP addresses. There's something called remote trigger black hole capability. That is when somebody is DDoSing a resource within your network, sort of a little bit shy of engaging a DDoS mitigation service. Most upstream networks have a mechanism where you can say, don't send me any traffic to this particular IP address, just drop it. So having that capability is important. And then, log analysis for your network devices. You probably do this for your servers, but you should be doing it for your network devices. Okay, so I'm going to go through just a few examples of when it's not super simple to make a ROA, just to give you a taste of the kinds of things that can make that more complicated. These are IP addresses and AS numbers that I'm just accustomed to. They're IUs, but I don't know if IUs ROAs look like this. Having the least specific ROA, the shortest ROA, is that will work, provides the most protection. So if you announce a 16, just having a ROA that says the only thing valid is R16 and nothing longer, that provides the most protection. Sometimes you can't do that. In research and education institutions, they may participate in certain networks, overlay networks, that require them to break their networks up into smaller bits. And they may need to have ROAs that allow those smaller bits. Some DDoS scrubbing providers have on-demand services. So you might have something that's monitoring your network for a DDoS attack. And when it detects one, it maybe signals to a service provider and says, okay, this particular subnet's under attack. Please draw all the traffic, all the attack traffic, and only return to me clean traffic. Well, when that happens, that may mean that you need to make an additional ROA to accommodate that new route. If the DDoS scrubbing provider originates that route from a different network, or it may mean that you need to use a feature called max length, which means you're telling a ROA, you're a ROA for /16 all the way to /24, for example. When you create, the other little complication is, let's say you have to make several ROAs for one network allocation. Maybe you have to make one for your DDoS provider. Maybe you have broken it up into a few pieces, and so you need to make ROAs for those. You have to create them in a particular order. And this is really important. So I'll give you an example. Let's say I had to make a ROA for the normal way I announce my route and a ROA for the way my DDoS scrubbing provider announces it. Well, if I'm not under attack, and the first ROA I create is for the DDoS scrubbing provider, all of a sudden my normal route will not be valid. And so I would immediately have cut myself off the internet. Now I say immediately, it might take minutes or an hour or whatever, but it might interrupt your session with Aaron, and you might be ready to put in that second ROA that you need right now, and you may be grabbing for a phone that you can tether off of from a different network to complete that. So the order in which you put them in will be important if they're overlapping. And this presentation isn't meant to equip you with the expertise to do this. It's just to point out the complexities of doing this in certain cases, because you have to get it exactly right or you risk an outage. These are just some other examples with different scrubbing providers, and they require different kinds of ROAs. Sometimes people have always-on scrubbing services. Cloudflare is a popular vendor for these. And in that case, you have to create ROAs for the prefixes that Radware is announcing. Cloudflare. And Cloudflare can't create them for you. So you have to know, oh, yeah, I'm using Cloudflare. They're announcing more specifics. They're scrubbing all my traffic all the time. I need to create ROAs that allow those routes to be accepted by the internet. These are just more examples of the same. So anyway, that's the message I have. So, in summary, there is an easy button. It should be on your list. It's filling out a form at Aaron. Sometimes that form can be really simple to fill out. Your BGP people will be able to tell you if it's simple to fill out or not. There's a test environment at Aaron they can use to practice creating these things. This isn't the only routing security item, but it's one that the federal government is really leaning on people to start to do. I mean, they're, in the FCC notice for rulemaking, they talked about making these requirements. It's considered a best practice. I think it should be a standard of care item. This should be, it should be expected that the networks do this. And the one last thing I will say, this is the first of probably 3 or 4 coming technologies that will improve routing security over time. And they're all anchored in the resource public key infrastructure at your regional internet registry, in most cases, Aaron. So you'll be creating ROAs today. You'll be creating something called ASPAs tomorrow. We won't get into what those are. And then ultimately, maybe before I retire, you'll actually be using BGPsec, which will be kind of the in-state, at least as we see it right now, for securing the routing layer of the internet. So, any questions?
Yeah. Are these supersede projects like
So that's a good question, and my answer is going to be a little long. So RadDB is an internet routing registry, and there is so I said ROAs are a part of routing security, but internet routing registries are another part of routing security, and it doesn't replace RadDB, but it adds a real complication, because if you create a route object in RadDB that is in conflict with a published ROA, it won't show up. And in fact, you can't create it. I mean, you could have a legacy one and it won't show up. If you create the route object and somebody later creates the ROA that's in conflict with it, it will disappear from queries. So RadDB looks at the ROAs and basically suppresses any records people have created that are in conflict with ROAs. So ROAs are the highest trust, I guess. There's also something called authenticated IRRs. So all of the regional internet registries, including Aaron, operate what's called an authenticated internet routing registry, where you can create route objects. In RADB, you can create route objects for anything you want. In Aaron, you can only create route objects for your resources. And so there are places where you need one or the other. There is some talk among the operators of this is getting into the weeds, of the route servers at internet exchange points, that they may start only sharing routes that have route objects in authenticated IRRs. So when you're in Aaron, and I realize this will be Greek to most people probably in the room, you create ROAs, but you can also create route objects. And you should create the route objects. They're far less touchy. They're not going to hurt you like the ROAs will. But it can. There's an article I've written about this and what it means on Internet 2's web pages. Over time, it's likely that networks that don't have route objects in the authenticated IRRs will have a less robust internet. Any other questions?
So, more, like, you know, uh,
Yeah, so there's some organizations who are uncomfortable with the terms in Aaron's agreement, and they have addresses that were assigned before Aaron existed. And among the Internet 2 higher education members, that's about 20% that are in that boat. Now, they've signed Aaron agreements for their V6 and their ASs and V4 they got later, but they might have a block of V4 that they didn't sign an agreement for, and they don't want to sign the agreement. And I know there are a group of CIOs that are part of the Common Solutions group that are attending the Aaron meeting, which is maybe right now in Toronto or next week. And they're going to lobby the trustees to make some further changes to the Aaron agreement to make it more acceptable. I say get involved with Aaron. Aaron's very responsive. The more they hear from people, what their needs are, they tend to be responsive.
right? Yeah. Back. Right. Or like a contract.
Right, only legacy space.
On the link.
Right.
Or, the area third already in that, we are ahead.
Aaron's careful to never say they own it, but they also don't think anybody else owns it. There's some people who are uncomfortable with those terms. I understand that. They should talk to Aaron. Aaron's made some major changes in the last few years. Unless Aaron changes their mind, it's too late to get the discount. But they should talk to Aaron. It's a hard problem. Yeah.
So let's say that your company did this, your CISO added on to it. It still seems like there's a supply chain issue with like the Google issue you're talking about. With the next step, need to go beat up your dependency site, but you got important.
So, I think Google's a little bit of a corner case, but they're big corner.
They're big.
Almost all the major ISPs do route origin validation, and the cloud providers, except for Google, do it as well. And I really think the problem is since Google built their own routing infrastructure, they just haven't rolled the feature out yet. So I think it's a good idea to say, hey, Google, why are you not doing the thing that everybody else is doing that's important to do? Oddly enough, if you want to bring your own IP space to Google, you have to have routes. So, and I think Google has rows for their addresses, but they don't do route origin validation. So I can't believe they aren't going to do it. I just think they just haven't gotten there yet. Anything else?
Well, I'm going to add one last point, just to kind of help with the call to action thing here for you all. After we had this type of incident we've hypothetically or parenthetically talked about here, one of the interesting things that we did, because we were really concerned that, hey, if somebody is going to illegitimately route our space off to the other side of the planet, what's going on? And we wanted to understand the malicious potential or whether it's accidental potential and everything else. But one of the interesting things that we did is we worked with the Utah State SIAC. You guys many of you should be familiar with who those folks are. But we did kind of an impromptu research project and looked at organizations around the country and looked at how many organizations don't have these protections embedded in them. Now, Steve's talking about it's 20% have them in higher ed, which is an abysmal amount. Many of you, or some of you in here, are in that education space and are in charge of security. Go ask these questions. But there's larger organizations, and where the SAINTCON community is so much larger than just education and such, you might be running a small to mid-sized organization that has IP address space that is vulnerable to this type of attack or potential abuse or mistake, whichever it ends up being. But it can be a significant attack. It's enough of a risk that we're bringing it here. We want to talk about it and get you to have it on your radar. Have it on your radar so it can be on the CISO's radar or the president's radar or other people, because it's not getting done with just the network people hearing about it at the conferences that they go to. And to take Eldon's point a little bit further, there might be complicated things that are influencing whether or not this adoption is happening. Maybe it's the Aaron agreement is we're not going to sign that because it gives away our ownership or our rights or other things. But I would say right now, more than ever, the question about whether or not something like this needs to be reassessed and reevaluated and apply the risk methodology to it as well. What's the risk now of not signing an agreement to be able to have some of these protections and things in place if that was the thing holding you back? So my call to action for you is go talk about this with the network people, make sure or evaluate this on your own. You can go out to there's several resources. Hurricane Electric will let you go out there and type in an IP address block and tell you whether there's an ROA for it or not. Go search and figure out whether you are vulnerable to this and start working on it.
So I will tell you, I do lots of reports on all the networks that are connected to internet too. And there are 800 separate organizations that have IP addresses where they have the Aaron agreement and they haven't created their ROAs.
Yeah.
And it's hard to move that needle. And it's worth doing.
Yep. So that's it. That's the talk. Thank you.
Thank you, Steve, for